In my last video on Ethereum 2.0, I told you about the incoming opportunity to generate some passive income by becoming a validator for Ethereum 2.0. You can earn between 5 to 20%. The big problem with becoming a validator on Ethereum 2.0 is that you need to lock 32 Ether for a few years. At today's price, that's about $16,000. Not exactly cheap. That's what we have some services like Rocket Pool or Staker that allow you to pool your Ether with other people to run a validator together. That's what we call pool staking. In this video, I'm going to show you how to build your own pool staking service like Rocket Pool. Not only you will be able to use this service for yourself as an investor, but you will also be able to charge a fee to other investors to compensate you for the service provided. Several streams of income. Very nice. I'm going to explain the code of the deposit smart contract of Ethereum 2.0, and we'll also build our own smart contract for the staking pool. And finally, we will expose all of this to users with a front end. And if you don't know me, I'm Julian, and on my channel Eat the Blocks, I teach blockchain development. And before we continue, if you are a beginner and you want to get started in blockchain, I'm going to do a free live training on November 27. This will be about how to get started in blockchain. It's going to cover how to get your first blockchain job, how to launch your own blockchain project, and how to make money programmatically in blockchain. So it's a live event where you can ask me any questions, and there will not be any recording available after. So if you want to participate, the only way is to register for the event with the link down below. This is totally free. You only need your email to register. So first we're going to see the architecture of our staking pool. So we are going to create a staking pool smart contract. That's where the investors will send their Ether. So they don't need to send 32 Ether, but it can be less. So there will be a fixed investment period, for example, 1 week. And once this investment period is over, the Ether of the staking pool contract will be sent to the deposit contract. That's the official smart contract of Ethereum that allow you to stake your Ether. And after you send your Ether to this deposit smart contract, it's automatically moved to Ethereum 2.0 as a stake that is associated to a validator. And after that, we need to run our validator node on Ethereum 2.0. So I'm not going to cover this part on this video because I already talked about it on my other video on Ethereum 2.0. In this video, we are going to focus on the staking pool smart contract. So for that, we are going to remix and we are going to create a new file, stakingpool.sol. Okay, so we're going to use the latest version of Solidity 0.7.5, and we define our contract staking pool. At first, we're going to define a couple of variables. So first, an address for the admin of the contract. This address will have a special right, and also an integer to represent the end date of the investment period. And we're going to instantiate these two variables in the constructor. So the admin is the address that deploy our staking pool contract. And for the end, for example, we can set it to 1 week after the deployment of the contract. Oops, forgot the parentheses here. And after, we are going to create a function to allow investor to invest Ether in the staking pool. So we call this invest, and we make it payable so that people are able to send Ether to it. So we need to define a couple of variables. So first, we need to define a mapping of addresses to integer so that we can identify what's the investing balance for each investor. And we're also going to define an event new investor to. This is going to be useful to allow investors to withdraw their investment on Ethereum 2.0. Address investor. Okay, so then in the invest function, we're going to first make sure that we haven't reached the end of the investment period. So the error message is too late. And after, if this is a new investor that has never invested before, we are going to emit an event, new investor. And after, we're going to increment the balance of the investor like this. So when the investment period is over, we will only be able to invest a multiple of 32 Ether, because the way Ether2 staking works is you need to run one validator per 32 Ether invested. But it's possible that, but we probably won't have an exact multiple of 32 Ether, since investors are allowed to invest any amount here. So once the investment period is over, we are going to execute another function that is going to tell us what is the amount of extra Ether that we have in the contract. And after, we will share this extra amount among all the investors. So we'll call this the change. So we're going to call this function finalize, make it external. Anybody can call it. And we need to define a couple of variables. So first, we need to define a Boolean variable that tells us if the contract was finalized or not. So basically, after we call this function one time, then it will be considered as finalized. Then a variable to tell us what's the total invested at the end of the investment period. Then what is the total change that we need to distribute. Then here in our function, we're going to first make sure that we are after the investment period. The error message is too early. Then we make sure that finalize is false, because we cannot finalize twice. Then we set it to finalize. Then for total invested, so it's just going to be the balance at the time that we call this function. And then for the total change, we are going to compute the remainder of an integer division of the balance of Ether with 32 Ether. So that's the modulo operator. So for example, if we have 33 Ether in the contract, the remainder of the integer division equals 1. And now we know how much we need to distribute to investors. Okay, so after, we are going to create a function to allow each investor to claim his change. So we're not going to distribute ourselves the change to all the investors, because it can cost a lot of gas, but it's going to be up to each investor to claim his change. So we create a function called getChange, and we need to create a new variable to store who has withdrawn his change or who has claimed his change already. So for each investor, we're going to associate this to a Boolean value, change claimed. Okay. And then inside getChange, we're going to require a couple of things. First, we want to make sure that we are finalized. Then we're going to require that the investor is actually an investor. MSG, the balance of MSG standard needs to be superior to 0. And the error message is not an investor. And then we are going to require that the change claim of this investor is false. Oops. Otherwise, the error message is change already claimed. Then we update the change claim mapping for our investor to true. Then we need to calculate the amount of change that we need to distribute to our investor. So for that, we're going to calculate proportionally to the share of the investment in the total pool. So total change times balances of our sender divided by total invested. And now we can just send this Ether. MSG sender send and this amount. Oops, actually here I mean to use transfer, it's safer. Okay, And next, we need to integrate our contract with the deposit contract for Ethereum 2.0. So for that, we're going to check out the code of this contract. So this is in the GitHub repo that's maintained by the Ethereum Foundation. So originally, this was a contract written in Viper, but it was rewritten in Solidity. So let's scroll down. Scroll down. And here the function we're interested in is the deposit function. So each validator on Ethereum 2.0 needs to call this function once and send it 32 Ether and specify a couple of arguments. So the public key is the identifier for the validator, the withdrawal credentials allow the validator to withdraw its stake on Ethereum 2.0. So of course, we are not sharing any private keys here. We're just talking of public information. And also a signature. So that's to make sure that the validator actually wanted to do this deposit. And for the deposit data route, I actually don't know. But all of these things are generated by the CLI tool that you have to use in order to create the credentials for your validator. So if you don't know what I'm talking about, check out my other video on Ethereum 2.0 staking. So you call the deposit function with this argument, you send it 32 Ether, and then it does a couple of checks here. It emits a deposit event, and that's all you have to do. After that, you have staked your 32 Ether, and you also need, of course, to run your validator node. So actually, the deposit contract is pretty complex, but we don't need to spend too much time try to understand how it works exactly. All that matters is that you need to call this function with and send it 32 Ether. So we are going to scroll up and take the interface of the contract. Actually, we just need this function. And here I'm going to paste the interface. Okay, I don't need this. Just the deposit function. And we also need to know the address of the deposit contract. So it's this one in Etherscan. So I'm going to copy here the address. Here you can see that it has a lot of Ether inside. And back to our code, going to paste this. Okay. So I'm going to create two variables. First, a mapping for all the public keys of a validator. So why we're going to do this, you're going to understand just after. Pub keys used, and also need to create a pointer to the deposit smart contract. Deposit contract, and we pass it the address of the deposit contract. And so with this, we can interact with smart contract. Okay, so after we are going to create the deposit function. Actually, I'm going to copy paste the signature here. Function deposit. It's not going to be payable. We only need it to be external. Okay, so I told you before that each validator is associated to a 32 ETH deposit. So what we're going to do after our staking pool has been finalized, that means the investment period is over and investor took the change. After that, as the admin of this contract, we are going to call this deposit function as many times as we need in order to stake all of our Ethers. So for example, if we have 64 Ether in our contract, so we need to call the deposit function 2 times. If we have 320 Ether, we're going to call the deposit function 10 times, etc., etc. It's not possible to just call the deposit function of the deposit contract once with more than 32 Ether, because the extra Ether associated to a single validator is not going to produce any extra income. So in other words, we're just going to waste our money. So we do need a different pub key here for each 32 ETH. So there is probably a way to make this more efficient with a deposit function that accepts an array of pub key, of withdrawal credential, etc. by using a specified encoding for bytes, and after you pass all of this in your function and you call the deposit contract of Ethereum 2.0, but it adds some complexity, so we're just going to keep it simple. So we're going to require a couple of stuff. Finalize equal true, too early. Then we're going to require that the message sender is the admin. So why we're doing this is because it's the admin that's going to run the validator node after. So it's important that here we put the pub key that will be run by the admin. Then we're going to require that the remaining balance of Ether on the contract is still 32 Ether, because we need to send this Ether to the deposit contract. And then we're also going to make sure that we haven't used this pub key before by mistake, because otherwise if we stake more than 32 Ether associated to the same pub key, we're just wasting money. It won't create any additional income. This pub key was already used. Okay, and after we're gonna call the deposit contract function, the function deposit. We're gonna send it 32 Ether, so that's the new notation to send some Ether to a smart contract with solidity 0.7. And after we specify all the different arguments, so pub key, withdrawal credentials, signature, deposit data root. Oh, and I realized I forgot one very important thing. We also need to charge a fee to investors. So here we go in the invest function, and we're going to calculate a fee. So for example, I don't know, 1% of the amount invested. And so we can send this to the admin. So admin transfer fee, and here it's not going to be MSG value, but it's going to be amount invested. And for the admin, we need to make it payable. Otherwise, it won't be able to receive the money. Okay, and we are good for our staking pool smart contract. So next, we're going to create the front end. Okay, so for the front end, we are going to save some time. So I'm not going to do live coding, but I'm going to walk you through the code. So here on the GitHub repo of Eat the Block, so this is the folder for this project, and I've created a truffle project. So I have my smart contract here, staking pool. I've also created a migration file here in a deploy contracts in the migration folder, and we're going to see the front-end code here in the front-end folder. So I've installed a couple of dependencies, so Ether to interact with the blockchain, as well as Bootstrap, the CSS framework, to make it look nicer. And the other thing is not me who installed it. I actually used a tool called Create React App. So that's a tool to easily bootstrap a React application. And so we're going inside the src directory, and so the action happened in app.js and ethereum.js. So first ethereum.js. So here we integrate with metamask, so the Ethereum wallet, which is a Chrome extension. So here we wait for all the web page to be loaded, and if we detect this object, that means that there is MetaMask. So we ask the user to allow our dApp to access its address. Then we instantiate an Ether's provider. So that's an object that represents a connection to the blockchain. So then I get the address of the user. Then I create this object that represents a connection to a specific smart contract, so the smart contract of the staking pool. And I return this to the caller of this function. And so after in app.js, So here I define my app component. I define a couple of states. So here the staking pool object that we created in the other file, the address of the user, and also the amount that was already invested by the user. And so in this function, what happened is when the component first load, this code here is executed just one time. We execute the get blockchain function I explained you just before. So we get these two things. Then with the staking pool object, we're able to get the balance invested of the current user. And after we save everything in the state of the component, the pointer to the staking pool contract, the address of the user, and the amount invested. Here, if we haven't loaded all the data yet, we just display loading. So here, this function, I'm going to skip it for now. And here, return, so that's where all the action happened. That's where we render all of our HTML. So here you see this class name. This comes from Bootstrap. It's to make it look nice. And what's interesting is here. So that's where we're going to show a form in order to invest in our staking pool. So here we have an input to specify how much Ether we want to invest, and here a button to submit the form. And when we submit the form, we call the invest function here. And here we call the invest function of the staking pool with the Ether amount that was specified in the form. And just after, we also update the amount invested variable because it has changed. And after, in the HTML here, that's where we show to the user the amount that was invested. So here I am in my project folder, and I'm going to start a truffle console. So it's going to start Ganache, the local development blockchain of Ethereum. And on this blockchain, I'm going to deploy my smart contract. I also start the front end in another terminal. I go in the front end folder, npm start. Okay, so this is in my web browser. So on MetaMask, I make sure that I am on the right network. I've already configured a connection to locals 9545. Also, yes, I've synchronized the account in MetaMask with the account of Ganache. And here in the settings, I'm going to reset everything. So every time you restart Ganache, you have to do this. Okay. And after, I'm going to invest, I don't know, for example, 1,000 away. Here, confirmation pop-up of MetaMask, confirm. And here you can see your investment variable that was updated. So it works. So what's the next step? After the investment period is over, you need to call the deposit function of the staking pool several times. You need one call per 32 ETH invested. You will need to provide validator credential to this function like public key, etc. And after, you will need to run all of these validators. I show all of this in my other video on Ethereum 2.0 staking. And after, when phase 2 of Ethereum 2.0 will be released, you will need to allow investors to withdraw their Ether. So phase 2 is still in R&D and probably won't be released before at least 2 years, so you still have time for this. But very briefly, you will need to create a withdrawal smart contract and deploy it to Ethereum 2.0. In this contract, you will have a function to allow investors to withdraw their money. You will also need to import the amount invested by each investor in the staking pool smart contract on ETH1 and import this into the withdrawal contract on ETH2 so that you can calculate how much each investor is allowed to withdraw. And after this project, if you want to build all the blockchain project, check out this playlist. I'll see you there.